Another basic skill that will be necessary to succeed in college algebra is working with radicals and complex numbers. In this video, we'll consider the complex number system. Recall, a real number is any number that can be located on a one-dimensional number line. Now, we actually have a larger set of numbers outside the real numbers that we use to solve problems today. This is called the complex number system. The complex numbers can do certain things that real numbers cannot do. For example, let's consider the real number square root of 4. The square root of 4, as you know, is equal to 2 because 2 times 2, or 2 squared, is equal to 4. I can square 2 and generate that radicand 4. However, let's consider the square root of negative 4. Well, the square root of negative 4 is clearly not 2 because 2 squared gives us positive 4. It's also not negative 2 because negative 2 times negative 2, or negative 2 squared, is equal to positive 4. So there's no real number that I can square to get negative 4. This requires the definition of a new kind of number, which we call an imaginary number. An imaginary number is any multiple of the imaginary unit I, where I is equal to the square root of negative 1 and I squared is equal to negative 1. So the building block for our complex number system is this imaginary unit I, which represents the square root of negative 1, not something that exists on the real number line or in the set of real numbers. And we observe I squared is equal to negative 1. So back to our problem, square root of negative 4, we say this is equal to 2 times I because 2I times 2I is equal to 4I squared, and because I squared is equal to negative 1, that's equal to negative 4. So imaginary numbers can do things that the real numbers cannot do. If you'll recall from our Venn diagram here, our real numbers, again, which can be located on the number line, are composed of subsets. We have our natural or counting numbers, our whole numbers, integers, rationals, which can be expressed as a fraction, and irrationals, which cannot be expressed as a fraction, numbers like e and pi. Uniting those together, we get our set of real numbers. Notice our set of imaginary numbers is disjoint from the set of real numbers. So those are the numbers like square root of negative 4. Now, our largest frame of reference for numbers that we have today is what we call the complex number system, and it's represented by the C with the double bar. A complex number is any number in standard form, written a plus bi, where a and b are real numbers. So a complex number has two components. It has a real component and an imaginary component. We're going to look at simplifying radicals that generate both real numbers and complex numbers. Now, just take a quick look at your calculator and observe if we type in the square root of 4, of course the result is a real number 2. But look what happens when I try to type in square root of negative 4. My calculator says, nope, you made an error. That's not a real answer. That's true. The square root of negative 4 is not a real number. So I'm just going to press number 1, quit. What I want to do is give my calculator access to that larger set of numbers that we call the complex number system. To do this, I'm going to press the mode key, and I'm going to use my down arrow key to get down to the line that begins with real. Right now, my calculator is in real mode. It will only calculate with real numbers. I'm going to change it over to complex mode by using my right arrow key to highlight a plus bi and then pressing enter. You'll recognize a plus bi is the standard form of a complex number. So I'm going to press second quit to get back to my home screen. Now let's see what happens when we evaluate the square root of negative 4. The calculator now tells us it's an imaginary number, 2i. Giving the calculator access to the complex numbers will allow it to evaluate square root of negative 4. Also notice what happens when we square 2i. So in parentheses, I'm going to write 2i Now, the I is located down here in blue above your decimal key. So to access it, I'm going to do second decimal. And then close parentheses and square. And we get 2i times 2i, which is -4 plus 0i in standard form. Or your calculator may just return the real number -4. So the complex numbers will be necessary to simplify radicands that are negative.